Okay, so yeah, quick introduction. I'm Wolf McNally, Blockchain Commons lead researcher, and I've been working on the Gordian Envelope. And this conversation, as Christopher was just saying, is about getting Envelope converted from its first language, which is Swift, to other languages like Kotlin and Python and so on. So today, I want to start by giving a kind of an overview of the Internet Draft. That's one of the major things I've been doing over the last month. Is we've decided that an Internet Draft is a working document of the IETF, and if it becomes a real boy someday, it'll be an RFC. So we all read RFCs. That's the hope, is that down the road this will become an RFC. But all RFCs start out life as Internet Draft, or just ID for short. And so I want to give you kind of an overview of that. Because that is probably the minimum viable implementation. There's a lot of things that envelopes can do, a lot of kind of code we've written around the capabilities of envelopes that have nothing to do with the core implementation or specification of envelopes. And so obviously, I think that, and obviously because the RFC, hopefully what it becomes an RFC, is going to be a standard for implementation for other people to follow, then being able to read that and implement it, obviously consulting with the reference implementation, that will be kind of a test of that document going forward. Then I will also want to go over some of the videos we've released recently, mostly having to do with the envelope CLI tool, which is the command line interface tool to access and manipulate envelopes, which is also currently written in Swift. And obviously having a version of that runs other places would be very useful. And then I want to just kind of talk a little bit about the state of the code, because I would say the code is mostly stable, and obviously depending on how it goes through the standards process, certain things may change. But and of course, where we're kind of adding new technology, like for example, recently in the past month, I added the ability to create proofs, inclusion proofs in envelopes, and that moved the code some. I made one breaking change while I was writing the first draft of the Internet Draft, in terms of changing a CBOR tag. And obviously we're going to make breaking changes. The earlier we do that, the better. And so I want to emphasize that what we're doing with envelopes is not in release state yet. Even if we're going to start ports, I don't expect things to change a lot though at this point. So assuming everybody likes the efforts we've been putting in, so it might change a little bit around the edges as we add additional functionality and conveniences. And then finally, I want to kind of go a high level tour of the existing code, the reference implementation, particularly focusing on the unit tests, which is if you're familiar with my other specification for uniform resources, URs, and their related functionality. We've had several successful ports of that done to other languages, and the advice I gave is start with my unit tests and get each one working in turn. And once you get through all the unit tests, you've pretty much got an implementation. So I hope that's true here as well. And then also just kind of some other points of interest in the code I'd like to cover. And because the envelope implementation is part of a larger framework called Blockchain Commons Secure Components. Sorry. Not everything in that framework is necessary or useful, and I just want to make sure I call out the parts of it that definitely have nothing to do with the core envelope implementation. They may be of interest, but they're definitely not necessary. So I want to make sure I call that out too. So that's the overall agenda. And of course, I like this to be interactive. So if you have questions, please feel free to jump in anytime. I'm probably not going to see raised hands very easily when I'm focused on all my spiel. So please just jump in and ask questions anytime that you'd like. So where would you like to take this at the moment, Christopher? Do you want to jump into the ID?
Yeah.
Take a moment to get that up, actually.
So right now, I think the key thing is that we want this to be a joint effort. Blockchain Commons doesn't have the experience with Kotlin at the kind of level that both Proxy and Bitmark have. On the other hand, I'd say we're probably a lot deeper than Swift than Proxy and Bitmark are at this point. So combining our efforts there. But also I see Ken and Ken, I think one of your other Proxy, Foundation Devices people here today?
Yeah, we got Matt Gleason, who joined the team recently, and he's working on the Python code base mostly at the moment. So my thought was that we would do a Python implementation first, and then tackle a Rust one later.
I think that sounds like a good path to me. Yeah. Rust, I have worked with Rust a fair amount, and I find that it's, it's obviously very powerful and very strict, but I find it's not the most productive languages I've ever picked up. So, I think doing something in Python where you can be productive very quickly is a great way to get used to the code and then move to something much more strict.
Right. So
like
for us, our existing code base is Python, so that would be why we tackle that first, and then we're in progress on a new code base that is fully Rust.
Mm-hmm. And of course, the reason why I chose Swift originally was because I'm, started out being an Apple developer, iOS developer, and of course that's Apple's, main language. But also, I think it's just a very productive language once you know it a bit. I'm sure every programmer would say that about every language, and I've worked with over 20 different languages in my career. But of all the languages I've worked with, Swift I feel like is one of the most productive I've ever worked with. So it's very easy to get my concepts up and running in Swift first, even though it's not an iOS centric technology or framework at all. Okay, so
that I wanted to in particular point out for the foundation devices and anybody else working on Python is that one of our main goals is to inform things where maybe we are a little bit too mobile centric or too language centric to Kotlin or to Swift, where the sort of older style and also the more interactive style of Python may inform us to make a better, more universal API or make some decisions there. So, that's one of the key values of having a simultaneous port to 2 different languages, is that we can address any challenges here and try to get them early, and hopefully they'll be good enough as people. I'm sure there'll be somebody out there who want to go to, JavaScript. Somebody else will want to go to Java straight, etc. And we'll hopefully, Kotlin and Java have some similar relationships, etc. That will have covered all the different bases. At least that's the hope.
Yeah, I think Kotlin and Swift probably has more in common than Java, but
yeah.
True.
If I can just jump in quickly before you kick off, Wolf. From our side, we have Piotr here as well. So we have Ish from Android side, and Piotr is one of our lead backend engineers, and he's working primarily in TypeScript these days. So for us, the interest is kind of several-fold, potentially using envelopes as the next iteration of all of our credentials and proofs, which we're currently generating and storing and signing in VC format. Potentially switching that over to an envelope structure so that we get some of the nice benefits with redaction and existence proofs and things like that. That's one area where I would like to use this. Then it's as an actual data storage and sharing mechanism in our Vault and in our request and response flow as well, where we currently use a essentially an encrypted ECDH1PU envelope. It's JWE based, but we could just straight up embed things in an envelope as well for sharing those data items. And lastly, which is how we started here, is recovery. So recovery information, recovery shares with embedded metadata that may be redacted. So splitting your recovery seed across multiple places and potentially embedding and eliding some of the metadata in those various places. So we kind of have multiple angles, which is why it's at least initially we'd like to explore what it would take to approach each one of those. And we don't have an actual design for how each one of those would be moved over to an envelope structure, but at least it's a start. So we have so to that we have Ish from Android and Peter from with his TypeScript expertise, where TypeScript might be maybe not too dissimilar to Swift with strict typing and but otherwise being a fairly expressive and dynamic in many other ways.
Sort of reminds me,
Yep.
there's another document that's in progress right now. We may have a draft tonight, but it may be next week on use cases. And we're covering a lot of the different kinds of use cases. Obviously the collaborative seed recovery that Bitmark and Proxy are talking about for recovering things, but also things like, how do you use it with a legacy protocol like WebFinger? I don't know how many people are trying Mastodon clients lately, but Mastodon has a way of basically saying, yeah, I have an account on this server that's very privacy problematic. They could just simply substitute it with an inclusion proof, and boom, you've added a whole bunch of privacy to a protocol that is out there now from the IETF. So we're going to try to detail all of those and some of the variants. There's also some herd privacy use cases, rather than having the classic verifiable credential of, oh, you've got a diploma. Instead, the college does one diploma for the entire graduating class. And because of that, you have herd privacy whenever there's kind of a phone home situation or whatever, because they can't distinguish who you are from within that class.
Right, it's like a inclusion proof of like whether you specifically included in that single diploma VC, right? Without revealing it.
Exactly. Yeah.
Cool.
I see Nicholas has his hand up. Did you have a question, Nicholas?
Yeah, I was wondering about what Simon was referring to, and I was wondering if the code is available on GitHub or some open source repository, so I could just have a look at what current uses they're making of, of the cryptographic envelopes that they've implemented.
You mean our current code?
Yeah.
Yeah. Do you have any open source code where you're using?
We don't right now. We do plan to open up a lot of it, but it's not open right now.
I think you have a PR into the Kotlin UR repo.
Yeah, I mean we're using the UR library from and we're using the SSKI library from Blockchain Commons. We're using UR from Hummingbird, I believe. But yeah, we don't, Nicholas, our specific, like our protocols aren't open right now, but I can certainly keep you updated on that. And happy if you just want to ask questions or chat about it separately, I'm happy to do that as well.
All right, thanks.
Yeah. Ken, you have a first use case that you're focused on?
Not at the moment, no. We've been too busy with other things to spend much time on this at the moment.
One of my wish lists is you guys are storing recovery information of different forms. I mean, not even necessarily SSKR. You're storing it just encrypted in a very
I mean, we could certainly replace our current backup format with an envelope.
Yeah.
We haven't spent any effort toward that yet, but I think we talked about that on one of the previous calls as well.
Yeah. Okay, sounds great. So let's go to Wolf and let's start the walkthrough.
Okay, great. So I'm going to put this link in the chat, and you're welcome to follow along in your browser. If you like, this is to our current draft of the internet draft, as they call it, the IETF, hopefully someday an RFC. I'm going to read the abstract into our record here, and then just kind of start going down the high level view here. But
let's share your screen.
The envelope. Yeah, let me do. Yeah, that's a good idea. There we go. Okay. So yeah, the envelope protocol specifies a format for hierarchical binary data built on CBOR. Envelopes are designed with smart documents in mind and have a number of unique features, including easy representation of semantic structures like triples, built-in normalization, a built-in Merkle-like digest tree, and the ability for the holder of a document to selectively encrypt or elide specific parts of a document without invalidating the digest tree or cryptographic signatures that rely on it. Okay, so some of this is boilerplate. So basically, this is a specification document. Certain parts of it are going to say it's normative, in which case, if you want to create a compliant specification, you have to observe those. There's all other sections are listed as informative, and I'll kind of call those out. I start with a high level kind of a comparison against a few other kinds of formats, and then go into a list of features. The digest tree, as I just mentioned, is one of the most important ones. And it allows envelopes to help basically be deterministic. And if you know what an envelope should be, you just look at its top level hash or digest, and if it matches, that's what it contains. It's designed with semantic structures in mind, like subject, predicate, object, or like Alice knows Bob. And the top level structural level is a subject followed by a set of assertions, which are predicate object pairs. And so, an envelope doesn't have to have assertions. It can just be a subject, which could just be just a text string, or any other CBOR structure can go there. It's also cryptography ready because it has a digest tree. You can add signatures and things like that refer to other parts of the tree. It's designed as a binary structure, and it's built on not just CBOR, plain CBOR, but there's actually a section of CBOR documentation that talks about deterministic CBOR. For example, if you have a map in CBOR, which is like a dictionary, you basically have key value pairs, and those keys have to appear in ascending order, and the documentation describes how you determine that ascending order. So there's only one way you can encode a map deterministically, things like that. So that section on deterministically encoded CBOR is incorporated into this spec. And you'll also see there's other places in the spec where I definitely take steps to make sure that a compliant envelope is encoded deterministically. So then there's encryption and elision. These are the two digest preserving and transformations of an envelope. So any element, and when I say element, you'll see what I mean. It's a tree of objects, all of which themselves are envelopes, but you'll hear me refer them to as elements of that tree. So any of those elements can be transformed. They can either be elided or encrypted, or unelided or unencrypted, and replaced with their full expansion. So these are two ways of essentially collapsing parts of envelopes. One removes the data entirely from the envelope and just leaves the digest in its place, and the other one actually encrypts and leaves the ciphertext in the envelope that declares its digest using an HMAC. So if you unencrypt that and then the contents don't match the HMAC, you've got a bad envelope. So so it's designed with security in mind. You can't just substitute one thing out of the other and not disturb the overall digest tree. And most of the digests aren't actually stored with the envelope. Most of the digests, except for encrypted and elided envelopes, you don't store the digest with those elements. That's computed when you load them in, and so that way what you get is actually what's in the file. So yeah, again, more boilerplate. So this is the start of the normative specification. And I use what's called CDDL, which is the concise data definition language, which is part of the CBOR specification. And so I'm not going to be defining things at the byte or byte string level here. It's not necessary because CBOR is a binary format, and CDDL is a very specific kind of way of specifying that. So so there's 7 basically. Envelope is an enumerated type. So like any enumerated type or enum, you have a certain number of cases. And so you see me use the term cases, and I'm always referring to one of these 7 cases. The cases are leaf, no value, encrypted, elided, and then there's 2 without them. There's right here, they all are. Yeah, so leaf, no value, encrypted, elided, node, wrapped envelope, and assertion. And so the top 4 here, leaf, no value, encrypted, and elided, have no child nodes in them, whereas the ones called node, wrapped envelope, and assertion have child nodes. So together they build a tree. And as I said, each of these, an envelope, and this is CDDL, this is a CBOR tag 200. So all envelopes are tagged 200, and they contain an envelope content, which is one of these 7 cases. So any of these 7 cases are an envelope when they're tagged with 200. Okay, so there's 4 cases without children, as I mentioned. The leaf case format is basically kind of the terminal case. It's any CBOR you like. And I often use strings as an example, but please don't think this is in any way a text format or limited to strings. This can be any binary that you can represent in CBOR, which is pretty much anything. And of course, CBOR supports arrays and maps and all kinds of things. All right, so and then there's a set of what's called known values. So by the way, the CBOR, again, you'll see that each of these things is tagged. So if you just look at the raw CBOR, like in the CBOR diagnostic notation, you'll be able to see what you're looking at. And you'll see some examples of that down below. But the leaf is tagged to 24, and that's because the existing tag 24, which is a low numbered tag, is already used for any CBOR data item. So we're using that here. The second is called known value, and known value because you have predicates, subject, predicate objects like Alice knows Bob. Well, the predicate knows is so common and generically useful, and I'll come to the ways that's a bit ambiguous in a moment. But let's assume we have a predicate that's just used everywhere. Well, there's no reason to represent more than a byte or two for that, and in using the string, say knows in that place is very kind of bloated. So the known value space gives us a way of using a namespace to use that's very large because it's the size of a CBOR uint, which can be up to 8 bytes, to assign parts of that namespace to things that are commonly used and much less, and typically much smaller than a string or a digest or something else you could use to represent a predicate. Then we have the encrypted case, and envelopes don't have to implement encryption, but I'm presuming that any envelope use case is probably going to be using encryption of some sort. The one cryptographic algorithm you absolutely have to implement is the digest, and we use Blake 3. I'll come to that in a moment. But we have a specific format for the encrypted case. We've already documented it elsewhere. It's in our crypto message documentation here, but I'm repeating everything that's important here for it. We use the Cha-Cha 20 and Poly 1305 for IETF protocols, and the fields of that are all represented here. It's important to realize that the additional authenticated data, which is data that's not encrypted but covered by the HMAC of Poly 1305, is used to declare the digest of the data that's inside the envelope. And that's the authentication tag for that here. So basically, you can't change that without ultimately disagreeing with the contents of the envelope when you decrypt it. And if the envelope doesn't match, then the whole digest tree is invalidated.
So if you wanted to include actual AAD in your encrypted chunk, you would just tag that on as an extra assertion instead. That's authenticated.
Yeah. So basically, the way I would include authenticated data is you'd sign it. Generally speaking, you can. There's no reason why you can't actually create an encrypted message using this. In the secure components, we have an object called encrypted message, and it implements this, and this is how it's serialized. But if you're using the encrypt function of the envelope, it's going to automatically put it's tagged, so it's going to put tagged data here, which is the digest that's of the ciphertext. But you can use encrypted messages anywhere in your envelope you like, and you can use the AAD field of those anywhere you like. It's just that if you tell an envelope encrypt your subject, it's going to do that. It's going because it has to preserve the digest tree that way. But you can still use that anywhere else in your envelope for like objects of assertions or whatever. Okay. So then there's the elided format, which is basically just a tag digest, and here's what that looks like. And it's a 32-byte digest with a specific tag. So that takes care of all the childless cases. The node case is basically the tree builder case, and it contains another envelope content object, which could be any of the cases we're talking about here, and one or more assertions. You never have this unless there's at least one assertion. And an assertion element can be itself another assertion or an encrypted. It can be an assertion or the encrypted or elided form of that assertion. And the API checks to make sure you can't hand just any envelope here. It makes sure, because an assertion has a predicate and object, and so it maintains that syntactically. The envelope isn't. These are the only 3 valid possibilities here. So you can encrypt or elide assertions as well, and that's fine. Okay, so then there's the wrapped envelope case. And as it says, a wrapped envelope case is used where an envelope, including all its assertions, should be treated as a single element for example, for the purpose of signing. So normally when you say sign this when you say sign on an envelope, it adds an assertion with a signature, and that signature applies to the subject of the envelope. Remember, there's one subject and multiple assertions. So, but what if you want to sign a whole envelope? Well, then you wrap it, and that basically you put the envelope content object inside this tag, and that becomes the case of the envelope. And then you can basically sign the whole envelope, including its assertions. And then there's the assertion case, and the assertion is again, this is the actual CBOR format for it. It's a tag. Then it has two envelopes, a predicate and an object, and these can be anything, as you can see. And generally speaking, people are expecting certain kinds of assertions in a particular envelope format. When you use envelope, you're basically defining a file format that's using envelope. So you're building on that. So you're going to define the predicates you use. They might be well-known predicates. They might be specific to your application. You're also going to define, what belongs in each position of your envelope format. And so you will probably want to create a specification document for that as well. We have some output formats for envelopes you'll see in a moment, which basically help you both understand the contents of envelopes as well as help you document and define the contents of your envelopes is what they should be. All right, so the next section, now that you basically now you know the whole binary format of envelopes. All right, so that's it. But how do we compute the digest tree? That's a separate issue, and that's very important because the digest has to be repeatable and deterministic. So this section is also normative, and it gives a little bit of syntactical thing of how I'm using these operators here. But then we go through the 7 cases again, and we talk about how you compute the digest of each one. So, for example, the leaf case consists of any CBOR object. Tagging the leaf CBOR is recommended. So please declare what you put in a leaf, but other than it just being a leaf, especially for compound structures. For example, if you put a CBOR array, it'll basically declare itself as a CBOR array. But what kind of array is it? It'll be nice if you put a tag there, but it's not. So that's one of the few places where I say recommended, not required, because it's your data. But in any case, the digest is the CBOR, and then just run that through Blake 32. That's the digest. And I give examples in all of these. In fact, I also give examples of here's a binary sequence. I pass that to a separate tool, B3sum, which is a Blake 3 sum, and it gives me that. And then I give another example of encoding using our envelope tool, the exact same subject, basically the exact same thing as an envelope, and then show that when you ask the envelope tool for the digest of that, you get the exact same digest. So everything is repeatable. And then known value case is, again, it's just the tag and the uint and the digest of that. Again, I give examples for all of these. The encrypted case, again, I show how you would create that, and then I show how you can replicate that. The elided case, the node case, and the wrapped envelope case, the assertion case, and then we talk about the envelope hierarchy. And this is informative because the exact when you see output like this, I call that envelope notation, and there's another one called envelope tree notation. You don't have to implement this because this doesn't have to do with how you read or write envelopes. This is more how you understand envelopes. All of our tools, and this is not, and neither of these formats are round trippable. They're both designed for insight, not for round tripping. There is another format called CBOR diagnostic notation, which you can use CBOR related tools with. You can, our tools mostly print CBOR diagnostic notation. We don't read it in, but that is supposedly round trippable. I think there's also a way of converting CBOR to JSON. I've never looked into it, but presumably that would be round trippable as well. But anyway, so if we have a concrete example of this envelope notation, we see the one subject and then we see 3 assertions, and these are surrounded by quotes because these assertions happen to be in their leaf case form. They're just a UTF-8 string, and so it puts quotes around them. If you see something like verify by without quotes, that's actually a known value, just a short integer that's been encoded with that. So it's important to realize that there, in an envelope, there's several what I call positions. There's the whole envelope itself. There's the subject of the envelope. There's each assertion. Oops. Okay. Then there's each predicate, and then there's each object. And those are positions, and those are all envelopes themselves. This isn't just a string, it's an envelope. So you can have assertions on assertions, you can have, all kinds of things like that. So, but each of these 5 positions has its own digest. Now, to show that, we have another output format, or if you say envelope tree, and then you give it an envelope, it'll actually put output this format. This is the same envelope, But now you're seeing the actual hierarchy of it. You see there's the top is a node, which has a subject and one or more assertions. The subject has its own digest, and this is just the first 4 bytes of the digest. The actual digest is 32 bytes. That gets unwieldy in text. And again, this is for your understanding, not for round tripping or anything like that. And then there's 3 assertion objects, each of which have a predicate and a predicate and an object. And all of these end up rolling up into the top level. So the assertion is a combination of these 2 things. The node is a combination of all these things. So this is another way of outputting. We recently added Mermaid output, which is a text-based graphic format. It's supposedly like Markdown for graphics. So you can ask our envelope tool to output in this format. And this is the same idea. You have a node, you have the subject, and then you have the assertions. These are actually in the order they appear up here, and then their predicate and object. And I actually want to dwell on that order a little bit too, because I remember how I said earlier that that the encoding of all the leaves has to be deterministic CBOR. Well, the encoding of all this is deterministic too, because the actual digest values here, you notice how they're in ascending order lexicographically. There's 1E, then 5.5, and 7.1. That's mandatory. You have to do that. The subject always comes first, no matter what's digest. But in a node, all these have to be ordered lexicographically ascending by digest, and that basically means first of all, there's no duplicates, so you can't have a duplicate assertion. And then they all have to be ordered they have to be in sorted order, or it's not a valid envelope. So it's basically, mathematically, it's just it's a set. So there are no duplicates and they're all unique. But in the serialized format, it has to be in this order. So the Mermaid output reflects that as well. These are also the order which you concatenate them to create the digest. You always concatenate the predicate, then the object, that rolls up to this. Here you concatenate this, then this, then this, then this, and that rolls up to that, and so on. So, these various output formats, they give you a sense of how things are computed. Let's see here. So the next output, basically, the section looks at, again, the 7 cases as the various formats. So if I said envelope subject Alice in the command line tool, then the envelope notation it gives me would just be the quoted string Alice. If I asked for it in tree notation, it would give me that. If I asked for Mermaid notation, it would give me that. This is the CBOR diagnostic notation. This basically is telling you byte for byte what you'll have here. You have but it's in CBOR. So, and then I actually give the CBOR hex. So this is the actual serialization. So these are, even though I say at the beginning here, let's see, I think I say it at the very top. Well, anyway, these basically can be, I say it somewhere, these can be used as test cases, as test vectors. So if you are basically generating these, you're accurate. So the known value case, same thing. I show you how to generate an envelope, which is a known value. You output it, and there's no quotes there, which basically means the code itself has that value baked into it. When you output it, that's how it looks. In Mermaid, that's how it looks. CBOR diagnostic and CBOR hex. I won't belabor this, but it goes through everything. So the encrypted case, that's what encrypted looked like. The 2 that can be transformed without changing the digest structure, encrypted and elided. I use dotted outlines for them to show that they could be substituted with their unencrypted or unelided format without changing the digest tree. And that's what gives the powerful ability for the holder of a document to elide or redact, depending on your use case, the actual data in the envelope without invalidating signatures, for example. So we go through that. We go through the elided case, the node case, the wrapped envelope case, and the assertion case. And again, so you have all those things. So then I have a section on known values. And again, I say this is an informative section because the known values are not at all locked down. There's certain ones that I have found very useful in doing my experimentation, and you've seen a couple examples of like the verified by, which contains a signature. Christopher and I are still talking about whether that's the best terminology to use, or whether there should be several, depending on whether you're saying something is true and correct, or whether you're saying something's authorized by your signature. There's a number of different possible use cases there, but it's a very large namespace. Like anything in CBOR, if it's a low number, it's going to only take a byte or 2 to encode. If it's a very high number, contain up to 8 bytes. So as a namespace goes, just like the CBOR tags themselves are regulated by IANA, I think that the known value space should, most of it should be just be open for anybody to use in Homestead for their own uses, but the very, very low numbers, we probably want to have a standards process involved in deciding what should go there. So these are the ones I'm currently using. And then I basically give the description of how I'm using them at this point. As you can see, there's ones that might be relevant, like SSKR share to the current attendees. There's ones that basically kind of reflect certain things that are used in the distributed identifier, the DID space, like controller, who controls this document. There's one for, here's a URI or some way you can get more information about what we're referring to here about the subject of this envelope. And so on. So you basically get the idea that these are things. We have a set of methods in the API that add salt, and the reason to add salt is to create a digest tree that's not predictable. Because if, for example, your known predicates are always the same low integer, you could just look at the digest and say, oh yes, I recognize that. Well, adding salt basically makes that impossible for people who just look like at a lighted, something that's a lighted. They say, oh, I can't tell what that is anymore if they're just looking at an lighted envelope. And then we have a set here. I actually give them their own space starting at 100. This is for, we have part of what the experimentation we've been doing has to do with distributed requests and responses. And so we have a set here just for that. Obviously if you've ever done remote data processing, you kind of recognize those. So section on existence proofs. And this basically describes, what they are and how they're used, and gives some examples. If we have a document here and then we elide that completely, so we just have an elided document, this has the same digest as the original document, then we can actually ask somebody, hey, can you prove that this document contains this assertion? And this is the way that would I'm not going to go into detail now. One of my other videos discusses this, but this is basically how you construct that proof. Which is essentially it's another envelope that is completely elided, except it definitely includes the minimum number of digests you need to prove that digest is part of the master envelope. In fact, just the root hash. And so I say a couple of notes about the reference implementation, mostly where it is, and we'll talk about that in a moment. We talk about future proofing here a little bit, some security considerations. There's going to be significantly more added to this, and then why we chose the Blake 3, well-known hashes. This is basically all the security considerations here, and then we are going to be requesting some CBOR tags from IANA, and these are the ones that we're currently using. Some of them are definitely used in this spec, others aren't used in this spec, but we're using them. So exactly how this is going to work out, we're not sure yet. And then, we have a proposed MIME type here, and then all the references. So that's pretty much an overview of the document. It took a bit longer to do that than I thought I would, but are there any questions before I move on to the actual code?
I'd like just quickly to say that there's a lot of things that aren't in that. We don't define what kind of keys we're using, et cetera. The only cryptographic object in there, the only choice that is part of the spec is Blake 3.
The reason why we actually have the specification for the Cha-Cha Poly in there is because one of our case types is encrypted, and so to implement that successfully, you need to know how to encrypt. But that is part of a normative section, but I'm not sure that will even be part of the normative section in the final RFC. I don't know.
Yeah, I mean we chose Cha-Cha Poly largely based on the fact that it is a single RFC. It's probably overkill. If IACR, somebody comes along and says, no, why don't you just use, the next generation, the X Cha-Cha Poly, or instead says, oh no, we've really got to do this in some kind of constrained hardware, do it as this particular, AES. I mean, all the AES modes are kind of controversial. They all have pros and cons, but if they say that that's what they want to do with that, we'll either pull it from the spec and say, leave it open, put it in the spec because they recommend it. But the one thing we can't change easily is the hash. And Blake 3 is not an IETF RFC. There is one for Blake too. They may complain. So that means if there's one big thing that may change, it would be the hash algorithm. But we're doing that so we can get through the IETF process.
There's no reason why we couldn't easily move to SHA-256 or whatever if we wanted to. But Blake 3 is kind of the relatively speaking new hotness, even though it's been pretty well tested. It's just not RFC. But my point, part of the point I make that is in the future proofing session, which I didn't go into when I was showing it, is that because we're using CBOR, because it's structured, if you come across, say, an encrypted message, it's tagged as encrypted message, then you open it up and it's not what you expect, you can say, I don't understand this. But what it may be is there may be another internal tag, which if you do know what to look for, you're saying, oh, this is not the IETF Chachapoly 20. It's this other method that is supported either by our own company or by a standard or whatever. So we can add other supported encryption methods without any trouble. The issue there becomes then part of what we'd like to be able to do is incorporate like old envelopes into new envelopes, things like that. Somebody hands you an envelope, then you can actually, sign it, elide it, put it in your envelopes. And so there needs to be interoperability for that. So we want to try to maximize the chances of having, interoperability among envelopes.
We really
one idea maybe, Wolf, is but and I agree generally that you want so you don't want really protocol flexibility there. You just want to specify one. That's totally fine. But you can define in the spec. You can define the encrypted message structure in terms of an abstract. You just say like this needs to be an AEAD cipher, right? And there's there's a standard abstract. All AEADs have plain text and ciphertext, authenticated data, and a tag, right? There may be, whether you're using AES CBC plus CMAC, or if you're using GCM, or if you're using Chacha20 Poly 1305, they all fit that abstract. Okay, so you can define that encrypted message as just a generic AEAD structure, and then say, hey, tag 202 or whatever you have specifically refers to an instance of an encrypted message using this AEAD cipher, Chacha20. But if somebody wants to define tag 400, which matches the same encrypted envelope, the same crypto message representation where the digest is stored as AEAD and sort of fits the same abstract shape, but uses a different cipher, then that's up to them.
Yeah, I think the encrypted message case will always have the same tag, but once you look into that as you're parsing CBOR, if you find it like an inner tag which says that you know how to interpret, then you know how to interpret that structure as an encrypted message, and any number of ciphers will fit in that space. But generally speaking, obviously we're picking one for our reference implementation, and I agree we can just say. Well, in fact, I do say this in the future proofing section is adding other tags is, we're kind of leaving that to the future to decide how to migrate the format forward. But the main thing is that we want to confirm both with ourselves and with the whole community that migration is certainly possible. What I think Christopher and I would prefer to avoid is a proliferation of non-standard kinds of things, because interoperability is important. So
but my main point was that I think in the spec it would be useful to have. I don't know if that would be a normative section or just informative, but it would be useful to have the crypto message defined in terms of an abstract AEAD interface rather than a specific Chacha20.
Yeah, well, I think that in the short term, probably just noting that even though that larger section is normative, that one section is informative and refers to the implementation in the current reference implementation, because we're not trying to push that format on the world right now. We would like the world to agree as much as possible, but we understand different people have different goals and have different interoperational requirements. So, but definitely we want to make it so that people can pick up the general architecture of envelopes, adapt it, hopefully in ways that are interoperable, and make it useful for their purposes. Okay.
Also, to be clear, there's a lot of things that we may want to spec say at the blockchain commons level as things we're working on together that we really don't want to talk too much about in the at the IETF level, simply because we don't want to raise the fact that, you know, hey, some of our customers are going to be demanding a curve that is not an IETF approved curve. We shouldn't have to deal with that in the IETF spec. So I want to be clear that there's a separation here on that. So I see you're just in. I resent we just had a review of the draft envelope internet draft, or draft of an internet draft, because it's not.
Yeah, it's an internet draft.
And we're recording this, so I'll make sure that you have an access to this link for it as an intro on things. We're trying to end by 6, so we should probably get to his other items, unless there's something you want to jump into right now.
Yeah, thank you. I can read it. I did pause how to read it and raise question later.
Okay. Okay, Wolf. Next slide.
Okay. Yep. So I'm gonna put a link in here. You won't need this link right now. This is where you'll pull the code from. I've made a commit as early as maybe half hour before our meeting. So you know, if you want the latest and greatest, and you've already cloned the code, you probably want to do a pull. But you don't have to follow along here. Let me share my screen here. Okay, so you're seeing my Xcode window. Let me adapt my window size here a little bit more to what I'm showing here. If anybody has a hard time with the type size or whatever, then let me know. So what you're seeing here is the BC Swift Secure Components repo code base. It's a Swift framework. And I'll try to make this not too Swift centric in terms of you know what I'm talking about here, but it's generally speaking one of the most important sections is the docs. This is all Markdown, and you can find that in the repo. And if you display them, then they all display a nicely formatted Markdown. But you know they include definitely a kind of higher level overview, and also these docs go into a lot of examples of use cases and so on, like collision redaction, existence proofs. Various kinds of how you do non-correlation with salting, what I call envelope expressions, which is essentially a way of transmitting various kinds of evaluatable expressions using envelopes, and other test vectors and things like that. So this goes into a lot more detail than the internet draft would ever need to or want to. So the next section I want to talk about briefly is the tests. Now the tests themselves are broken up. So there's a number of things here that are for the framework as a whole, which includes things like seeds and passwords, which are based on, I don't remember the name of the algorithm at the moment, but things that are not necessary at all for envelopes. And so most of this stuff can be ignored. What you really want to pay attention to is what's in the envelope folder. And under, for example, basic tests, I basically have a number of, test envelopes, and then various kinds of examples. For example, this is one where I'm just creating an envelope where the subject is 42. And I have, something to check my encoding to make sure it round trips. And, you don't need this in production code. This is where I basically make sure that everything round trips between CBOR and back. And then basically I'm saying, okay, print this envelope in annotated CBOR diagnostic notation. And so again, this is reflecting the actual bytes that were output. And then I make sure the digest is consistent, make sure its output format is consistent. And then I make sure that when you extract the subject envelope back to an int, you get 42. Now this is one place where I'm using kind of the Swift type system. I'm saying that the subject needs to be deserializable back to an int. So hand me back this as an int, and it's going to throw an exception if it fails. So, and so you'll find that the exception system is used a lot in my API. So, I make sure, because CBOR has a different type for negative integers, and make sure it can handle negative integers, and, make sure that I have, as a basic envelope with a text that, basically I'm doing all kinds of sanity checking basically here. Then I have a set of tests that are for basic cryptographic techniques. I have, a plain text hello here. make sure that you can extract it back to its original form. Then I have, basically various kinds of use cases here. Alice signs it and sends it to Bob. This is what the format looks like when you output it. Here's this is the subject, and then the predicate object pair, which is the signature on the subject. And then Alice sends it to Bob, and then Bob receives the envelope. And basically, I'll walk you through the whole scenario of what the code would look like on both ends of Bob verifying the signature, and then multi-sign plain text with more than one signature. And kind of a making sure that a threshold signature works, symmetric encryption, and this is the encrypted arm of the envelope, the case of the envelope, which is the cha-cha poly.
Well,
testing round tripping. Yes.
Does it make sense for us to order these rather than alphabetically? Have, for instance, a lot of these are not critical right now, especially for
yeah. I mean, I think I'm going to be accelerating here in a moment, but okay. I'm not going to go through every single line here. But I kind of want to give a sense to how I'm testing, because if you're going to be replicating these tests, then understanding that that there's certain requirements. For example, the symmetric key object here, is something you'll need to implement from the library if you want to actually test these kinds of things. If you're going to put an envelope in UR format, you're going to need the UR library. If you're not, then you're not going to need that. So you're going to run into things in my tests that you're just not going to need if you don't need them. So feel free to skip over those things. But all these tests basically here are also kind of talked about in the documentation. But this is the actual tests that run those tests that are in the documentation. So it's important to understand that. And then, for example, diffing is something I'm working on right now. And this is the tests I've been developing for that. And elision is, basically, gives examples of how you would create a credential, transmit it, elide it, sign the elided version of it. And again, the documentation discusses this. This is the actual running code. So for example, in Xcode, I just click this and it would actually run the test. There's some very basic encoding tests here. This is very simple envelopes, but checking all kinds of different use cases. This is much required if you want to make sure you're compliant. You have some deeply nested envelopes, things like that. Various kinds of formatting tests to make sure that my output formats all work correctly. Various kinds of nesting tests in terms of, again, how the various ways that envelopes can be nested within envelopes. Testing for non-correlation using salt. You see there's the salt object here. This is testing based on existence proofs. And what I call scenario tests are essentially kind of more complex, more close to real world examples. And this one's is book metadata, and this is various kinds of, I didn't know all that code was commented out. I should clean that up. But verifiable credentials, things like that. And then, just a couple examples of how, to make sure certain kinds of things are encoded directly that I just had bugs and I need to chase down. So all the other test vectors in here have to do with, let's see, that probably shouldn't even be there. I don't know, because that's probably vestigial. Anyway, but these are other things that have nothing to do directly. But if you're implementing, for example, SSKR, you're going to want to make sure that you implement these things. So anyway, and then, for example, Blake 3, these are my tests to make sure I pass all the Blake 3 test cases. Okay, so in terms of the actual code itself, if you go into sources, you'll see that it's also broken up kind of by functional area. There's all kinds of things here which may or may not be relevant depending on whether or not you're going to use them. The core envelope implementation is actually here. So the envelope code is actually one of the more kind of, this is the actual envelope API. And this is where envelope is actually defined. And here are the 7 cases. And they are literally enum cases in Swift. And you see that each of them has, like in the case of a node, just like as advertised, it has the subject and a set of assertions. Several of these also have digest, and these are calculated as the envelope is read in or modified. In fact, the basic way I'm doing my API is that envelopes are never modified. They're basically immutable. And as you ask for various kinds of things like add an assertion, it hands you back another envelope which has that assertion added to it, and all the digests are updated on it. So in in data structure parlance, this would be the envelope is a value type, not a reference type. So, so you don't mutate envelopes directly, but you just basically kind of throw away the old envelope if you want to add an assertion, and then you work with the new one. So these digests are all basically pre-calculated based on the what's read in or how the API is manipulated. And then encrypted message is the actual encrypted message type. Digest is another type, and assertion notes these don't have digest declared because they declare their own digests. For example, if we go into the assertion type, again, predicate, object, digest, they're both envelopes. So just as advertised, it's pretty straightforward. Then I have, and again, from a high level point of view, there's like, if you want to do mermaid output, that's how I do mermaid output. If you want to represent an envelope as a generic graph structure I have another framework I use called for graphs that I wrote that represents that. That's used by Mermaid. Tree format output is here. The envelope notational format is here. Certain things are here I use for my remote API stuff. The known value implementation is here. Parameters also part for remote API. You probably don't need that. So mostly what you'll need is in envelope. And if we just kind of look at the high level overview of that, there's basically a number of different attributes on envelope that you can ask for. You can ask for, like, for example, you can ask for an envelope's predicate. Now, if it doesn't have a predicate, you're going to hit back something that will, throw an exception if you try to dereference it. So because only assertions have predicates and objects. So you can also ask for, you can do a switch on an envelope yourself and determine and based on what type it is, you can manipulate differently. If you're working at a high level, you never need to do that. You basically initialize an envelope with any object that's representable, and it figures out what type it is and figures the proper representation for it, and then creates the envelope. If you want to create an assertion, you give it the predicate and the object, and it figures out again what it should do for that. And if you have a specific known value, because you can represent those symbolically in Swift, there's a case for that. But this is the way that users of this API will generally create this. These are public on envelope, whereas there's a bunch of other initializers here, which are private, which are basically just used internally, and they're basically just part of the internal implementation details. But obviously, if you're implementing, you will need to look at those. You can ask for every single digest in an envelope. There's a number of methods here which walk the whole envelope tree, for various purposes. You can ask for the CBOR encoding of an envelope. You can decode an envelope from CBOR. You can extract the subject as a type of an envelope. And again, it decides based on what case of the envelope we're talking about, how to do that. You can wrap an envelope in another envelope, unwrap an envelope, things like that. You can wrap in an envelope, but if you try to unwrap something that's not a wrapped envelope, it'll throw an exception. So, I try to make it so that all the standard cases are covered very easily.
So
envelopes themselves being immutable. Yes.
Is there obviously we've got multiple people who are going to be working on this, and it feels like there's probably like 6 or 7 things that have to be done by the first person because everything else won't work until you have at least those. And then there's potentially dividable work where, say, the Python team, has, the basic envelope and a couple of other digest things working, the core baseline. And then one person goes off in the direction of, oh, well, we're going to support known predicates. I'll focus on that one. And the other one goes, oh, well, I'm going to support one of the other things. Do you have an idea in your head, like what is the minimum set? Because that probably has to be done by one party for each translation first.
If I were implementing this from scratch, say if I were taking on, say, a Python, implementation or whatever, I would start by figuring out the right way to implement these 7 cases in that target language. I would implement them at least as stubs. So, obviously, this is a self-referential case. In Swift, you have to declare indirect in other languages. I don't know what the idiom would be. But because the case refers to its own case, that's required in Swift. But basically, if I didn't have a Blake 3 implementation yet, that could basically be serialized to CBOR or whatever, I'd put a string in here as a placeholder, until one of my team members, say, came up with the proper Blake 3 implementation, and it passed its tests. I would, implement the assertion type. I would still have a case for encrypted, but if I wasn't ready to implement the encrypted message here, I would just basically, put something as a placeholder in there. I'd start as a top down, and this is the top. This is the very top, and put placeholders in, but get all 7 cases in, so that, as you add other functionality, then, you basically have that. The next thing I'd probably do is implement digests, and most of these, you see most of these just return the digest that's already been pre-computed on that. And because, basically I wanted this to be an O of 1 time when you ask for a digest, so it doesn't actually compute any digests. They're basically cached. And then, but basically one of the most important things about envelope is their serialization. And so when you, let's see. When you ask for the CBOR of an envelope, it gives you, I basically have usually tagged and untagged versions of the CBOR. So it asks for the tagged version of the CBOR, and then it basically asks you, and then that basically wraps the untagged CBOR in a tag. And so this is basically how an envelope is serialized to CBOR. Now I have a CBOR library in Swift, and you're going to want some kind of CBOR framework in your destination language. But basically based on what it is, it basically asks for example, leaf, it just basically encodes that leaf with a CBOR tag, and that's it.
And that's already been done for Python, right? We already have a CBOR library in Python in the port of.
Well, pretty much every language has a CBOR library, so you just need to pick one.
Ken, did you use?
Sure.
Did you port out?
For our implementation, we just made a really simple implementation that was just what was necessary for UR.
The main thing that I would advise about the CBOR implementation, especially if you're ever going to use CBOR maps, make sure it does deterministic encoding of the maps, because if it just does uses some kind of internal hash table that could be different on different runs, you won't get deterministic CBOR. So you need to make sure that the keys are always sorted ascending according to the deterministic CBOR specification. If you're just going to use stuff that's always ordered, like arrays, or of course assertions have to be ordered by digest, then that's not a problem. But maps can be a problem depending on your CBOR implementation. But yeah, this is basically it. And this is, for example, certain things here are, recursive, because, it's going to basically, for each assertion, it's going to append the assertions and add all those. The wrapped asks for the untagged CBOR of that, which is this, and then wraps that in a wrapped envelope tag. So this is a recursive method here. And similarly, the same idea is true for the reverse, the deserialization. You start with some CBOR, and then you basically determine what tag is there, and then you drill down based on that, and you basically reconstruct the envelope. And certain things, like if it comes across something it doesn't understand, you got to throw an exception. It also, for example, once it determines all the assertions, it's going to basically initialize that with the subject and assertions, and that particular initializer is actually going to go and validate those assertions as well. It's going to make sure they're an assertion or an elided or an encrypted, and if they're not, then it's going to throw an exception. So when you read things in, everything gets validated, and all the digests get calculated as well. So when you say, for example, let's see, like known value, for instance, if I go to the internal initializer of known value, it's going to say, okay, known value knows how to calculate its digest. So it's going to basically say this self is this case with this known value, but it's also going to pre-calculate the digest at that point. Known value is a digest provider, which means it knows how to, and this is where I use a Swift protocol for digest provider, knows how to calculate its digest. This creates a digest object from the image, which is just the tagged CBOR. And so, that's kind of critical to implement to be able to serialize and deserialize envelopes. But, I definitely recommend, rather than just trying to work from the raw source code, get an Xcode, if you don't have a Mac, and get a Mac to work next to, so you can actually click through on some of these things, because it's really valuable to be able to command click and just have it jump to the definition and see these things as you're trying to do a parallel implementation. So I wouldn't try to do it without a Mac handy somehow, because there's a lot of cross-referencing. So I think that's enough to kind of get you started. You get the idea. We have some time for questions
I
and
was going to
conversation
ask
here.
if Ken could, so Ken did use this same kind of test thing in your UR library to port it to Python. What was your kind of experience or advice after porting it, Ken?
I did what you said earlier, essentially, which is I picked the first unit test and just wrote the code that was necessary to make that test pass, moved on to the next test. It was really function for function, test for test, is how I was implementing things.
Any particular challenge areas or external libraries that needed to be written from scratch, like you mentioned, Seaborg?
No, I don't remember any. It actually went really quick. It only took me about 3 days to get it all finished and working and tested, but I think even less than that, actually.
Cool.
Yeah, I dare say this is more complex than yours. And of course, there's several different tracks of testing here. So which one you pick first might depend. But for example, I might start with, let's see. Not sure there's as clear a starting point here, but basically basic tests, I think, is one of the better places to start. For example, like, an int subject here. It basically, it shows you the output formats. You probably should have at least implement one of these output formats so you can see what's going on. The actual implementation of how I do, envelope format, envelope notation format is here. It's a bit involved and it's all recursive. So, but it's text processing essentially. It walks the tree envelope and figures out how to convert that into text.
That's all stuff we definitely would do. I mean, that's so handy. So
yeah. And that's the kind of thing where, you can kind of, if you have more than one engineer on it, you can kind of, divide along those lines as well. But until you actually have the very basic top level envelope structure, it's gonna be hard for anybody to do any stuff to anybody. But yeah, it's and there's certain kinds of errors that the envelope API throws. It definitely prefers throwing errors rather than having you try to detect error conditions manually. And and pretty much I would say
there's some Seaborg tools and other stuff that you have at the command line that aren't ours that you might want to share what those are or document those someplace.
There's also
go ahead.
I was just going to say there's also the issue that with Python not having data types, basically like structured data types. The schemas, we may in a Python one, I'll probably want to add more the ability to do more validation on parameters and things like that, possibly optional.
Yeah, I mean, I think the API is going to look somewhat the same, but somewhat different as well, because I very heavily rely on the Swift type system in my envelope API.
Yeah.
You tell it what type of object you're expecting back, and it throws an exception if it can't get it. So things like that. But I've tried to break things up by kind of functional capacity here. And there's tools like add salt and so on, which can come way later. And it should be fairly obvious what needs to be done earlier than later. It's so while it is more complex than you are, I don't think it's going to be terribly hard to get a basic implementation. And then, but as you look through each of these functional sections, for example, if they're closer to the top, they're probably more important. And if they're closer to the bottom, they probably came later, and they're therefore building on the basic thing. These internal initializers are pretty important because they're used by all the public initializers.
What should they do last?
What's that?
What should they avoid or do last?
The stuff at the bottom, I would say, and that includes, for example, this is like init with function. This is like stuff that has to do with my experimental API for remote function calls, and it basically relies on the basic implementation. In some ways, this should probably be broken out into a different file. In fact, that might be a good next task for me, is just basically kind of break up what's very important. And then if there's things like UR encoding, which is not necessary for envelope. Envelope is not in any way requiring URs. We use them a lot. But if you don't need URs, you don't need to have anything here dealing with URs. But for example, this section where you're encoding and decoding tagged and untagged Seaborg, that's super important. being able to do certain things, like if you want to do elision, all the API for elision is here. And this is proof generation here. So it should be pretty obvious what what's important. If here's encryption and decryption. So signature verifying, adding and verifying signatures is here. So it's kind of broken up by functional area. This is split and join, split and shares and initialize with shares. That's all SSKR stuff. So at this point, I haven't done a very good job of separating what's essential to the envelope concept from additional functionality like SSKR, but it shouldn't be too hard to tell them apart. And if there's a strong enough feeling in the group that ought to be something I devote myself to next, I can certainly do that.
So Simon, thoughts?
Yeah, the main thing I just kind of want to get some feedback on from everyone else is in terms of just high level API. So just looking at this Swift code, I think mapping onto Typescript's type system would be pretty straightforward. It can basically be pretty much the same API because it natively supports, enum types and things like that, enumerated types, as well as interfaces. Kotlin, I think, Ish, maybe you can correct me. I think Kotlin supports enumerated types as well as a native construct. Python kind of doesn't, right? So, sorry, go on, Ish.
I was going to say I need to check that.
Yeah. Yeah, but like Python doesn't, and it doesn't have a strong type system. So
but you can use tuples, for that, for instance,
Right. So exactly. So it would have to be some sort of like, I guess you guys would have to come up with how to represent an enumerated type in Python, right?
Yeah, there's some code we use for that right now already, like a capital E enum sort of class is one option.
Oh, one other area that I might want to show you in the code real quick, because it's fairly relevant for implementers. There's a file called Cbor tags. Oops, not Cbor. That's my Cbor encoder. But the Cbor tags, they're here. As you saw in the internet draft, many of them are relevant to this. The 200 tag is here. This is how I define them, but you'll probably want a central source of truth in your code for at least the tags that you're using and that work with the spec. I have a lot of other things that I hear for like EC keys and things like that you may not care about, or PSBTs, which are this is part of our support library for the work we do with Bitcoin. So some of the things just won't matter to you, but other things will be pretty critical. These are the tags I mentioned regarding my function parameter request and response stuff. And then I have basically kind of like a database of known tags. So when I output this is like annotated diagnostic notation or whatever, I have a quick way of figuring out which known tag we're talking about, which known and annotating the output. So, but yeah, so that's just my source of truth for those, those known numbers.
So right
I also do have another one called known values, which is basically where I actually have my source of truth for the current known values that I'm currently using. Go ahead, Christopher.
At this point, the things that are most changing could be that it's going to be this envelope diff, and as Wolf just pointed out, the calling parameter, crypto request stuff. So the goal with, you want to describe the diff problem, and then because people may not be familiar with that one, just real quick.
Well, you're right. So yeah, so I mean, just like when we thought about doing cryptographic proofs, we needed to come up with a way of, say, proving that something exists inside the envelope. And to do that, that turned out to be creating another elided envelope that has what you need in it. Well, in this case, the idea is, well, how do you create an envelope that essentially shows the difference between two envelopes and lets you maybe apply that difference to another envelope in a kind of get style or merge, say, signatures onto, like if there's a document and Alice and Bob separately sign it, is there an automated way that you can merge those envelopes? And so the idea of creating a generalized kind of diff algorithm is what I've been working on. lately, and because we think that would be have generically useful to the community. The work I've done is on that so far is in the envelope diff. As you can see, there's even a couple of warnings still in there because it's still, and there's still some to-dos in there. So there's some certain edge cases I'm still working on. But I think the approach I'm using is sound. The one called diff tests, for example. There's some trivial test cases here, but this is what a diff looks like essentially. It says, and this is a string right now. It'll be it'll be a known value when I'm done. But this says, don't change the subject, but edit the assertion with this digest. So the object is now Dan. Delete this other one. So there's basically 3 edit operations: update, delete, or third one. Well, leave alone basically. So and then so you can see there's various kinds of things here. I'm checking to make sure they all round trip so that you can take 2 envelopes, diff them, apply the diff, and then the 2 equal each other in the end.
So, this particular, if you think about what a PSBT is in Bitcoin, this is what we're trying to do with envelope, where I could pass around an empty envelope, have various people sign their appropriate parts of it, and assemble a new envelope that is that is the joint approval of that particular thing. So
that's what I'm actually doing here. I'm creating a document, and then it's being signed by 2 separate parties, and then making sure that you first of all you have to make sure they sign the same document. You calculate the diffs, which is basically just the signatures, and then you apply them by applying the diffs separately, and then you get the actual document with both signatures.
So I don't know how important that is, and that's kind of what Wolf's working on right now. But we need feedback from your teams. Like, do you want, is this something that's important to you, or should I have Wolf go back and kind of refactor these envelope tests to make it easier to decide what to do first? So that's some feedback I'd like to get sooner than later from you. I want to be careful about time. Do you have any thoughts? And then also, I see Sean is back. Any thoughts on kind of team and priorities? I think Simon, your team is ready to begin work, as I understand, right? Or at least one person is. What's the schedule? Simon.
Yeah, I think we'd still need to figure that out, but at least yeah, I think we'll go back with the information we have here and see how many hours we can commit, basically, both from the Kotlin side and from potentially from a TypeScript side as well.
Okay. Well, Nicholas on our side certainly can review some PRs and things of that nature, and I hope that there's some time for in the short term for Bitmark to do so. Or Sean, do you want to talk about kind of when timeframes for beginning to take this ability to review PRs or actually do new code?
Sean, you want to talk on me?
Yeah. Do you have any thoughts on, when would you be able to start reviewing PRs from others versus actually, tackling one of the subparts and start implementing some of the tests and such?
So, sounds. You want to talk, right?
Yeah.
Sure. That's okay. Yeah. Yeah, I can talk.
Okay.
Can you guys hear me? Okay.
Yes, we can.
Okay. So, we have really right now we only have one person on the team that's familiar, like specifically with Kotlin, and it's hard to say like how much longer. We have some really big things coming up in the next 2 weeks, and so I don't know if we'll have much time in those 2 weeks. But yeah, I mean, I would say like after December 3rd, we should have significantly more time.
How about you know, if is there any time to say review PRs if, you know, Simon's team starts on some of the basic stuff? Can that one person maybe review some PRs? That's not as substantial work. Anyhow, I don't need an answer right now, but think about that before December, especially if proxy gets started early.
Yeah.
Yeah.
I mean, definitely, like, what I would say is to just push stuff towards us, and then we'll do our best. It's not like we won't look at it. So please push things to us if you have anything. But for us to actually like put an engineer to start working on stuff, the person that we need is really overloaded right now. With 2 exhibitions, one coming up in 2 days and one coming up at the end of next week.
Oh, by the way,
By the way, I hate to interrupt, but I'm up against my hard stop, so I have to leave. But I really appreciate the opportunity to present, and you know, thank you so much. And I'm at your service when it comes to questions or whatever. You can reach out to me on Signal easily, and if you need, we can get together on Zoom at any time. Just reach out to me. Sorry about that, Christopher, but thank you.
Yeah, the Gordian
Sure.
channel is the best channel for the group right now.
Right.
Okay. Okay, so I guess the other, you know, feedback is, you know, does Wolf need to go back and refactor the tests in this interim? Is it worth the effort? You know, especially if, you know, I don't know when, Simon, your team might be able to start on stuff and submit PRs for review.
Yeah, I mean, so from what I saw today, I think things are fairly nicely structured and separated. So I actually think it's once anyone can start, it's like the actual process is pretty straightforward. I don't think there's a lot of refactoring or anything that needs to happen. So yeah, from that perspective, I think it's fine. It's just going to be as you said. I agree with your statement that I think the first kind of skeleton of this, which is probably just defining the top level enum types, is probably something that's best done by one person to just set up a project structure and define those top level types, and then the rest of the implementation can be collaborated.
Great. Ken, any thoughts? I know you're you know, unlike Bitmark and Proxy, who both have some immediate needs for envelopes, your need is less immediate.
Yeah, I'll circle back with Matt probably tomorrow, and we'll figure out and with Zach and see, like, do we want to do something with the backup file in the short term? But I do want to, you know, be contributing toward this because we're definitely going to use it. I'm just not sure it's going to be right away. Is there anybody else like waiting for a Python implementation?
Well, we're just beginning to evangelize in the IETF community. It turns out there's a number of protocols that don't even require signatures. I mean, you know what WebFinger is?
No.
So WebFinger, it's used by Mastodon and a number of other protocols, and allows one server to sort of say, hey, is this account on your server? Is it active? And, you know, is it an alias? Give me the alias, et cetera. And so that's how, like, Mastodon routes between different parties. And it's an IETF spec, but of course it's extremely privacy bad in the sense that, you know, you've now exposing every single account on your server, and there are people that are crawling these things. So instead, you know, you could do an elision type of mechanism that says, well, we'll give you certain types of information. Or, you know, if it's being used in a thing of, you know, hey, you know, Christopher wants to prove to Ken that, you know, his Mastodon account is on such and such a server, I just give you an inclusion proof, and you can compare it against the server and know that, because, you know, that I have an account in that server without revealing anything even to that server that you're interested in communicating with me. So, and that doesn't even require any signatures because the signature's in the TLS. So trying to drive these things forward through IETF, having some more people there, and I think they're going to be doing stuff in Python and related in the short term. So I'm hoping we'll have some more Python people soon.
Yeah, sorry, go on, Ken.
I just said okay. That sounds fine. maybe we can pick up that topic again when it becomes more urgent.
Yeah.
Yeah, and then separately to like the pod implementation, Chris, I'd like to spend some time working on use case and basically writing up what our use cases would be, like the ones I mentioned at the beginning of this call. Probably wouldn't be able to get to that until December-ish, but I can maybe work with you on that, and as additional use cases, basically. And that'll for us, that'll serve as internal documentation for ourselves, how we want to use this for our use cases, and then for you, that will provide additional use cases to point at.
Yeah. So we have a start on 2 very large use case documents. So that's the first one in the chat. And this is the second one. They're kind of large because of the mermaid diagrams. Here's the second one. Anyhow, so you might want to look through those, and we can certainly have a dialogue, and anybody else who's interested in helping us come up with more use cases and follow through. At some point, right now there's a proliferation of them and we need to focus, but I think that we're trying to represent a fairly powerful functionality. So well, thank you. I think we all need to be heading out. But I have a video of this that I'll share with everybody, and I don't think we've shared anything proprietary at this point about different companies' plans. So the whole video, I'm just going to share the whole video, and hopefully we'll get some more people join us. Okay, any last comments from your team or yourself?
Yeah, I'm sorry, I just joined at the middle of the meetings, but I can briefly understand the structure of the code. So I need more time for me and the team to read through the document and the code and try to understand. And maybe we could have more time on December to review the code and make some contribution.
Fabulous.
So I will get back to Son and to you about the team's efforts on December. So
great, thank you very much, and I'll have the recording up tomorrow. Thank you, everybody.
Thank you, Christopher. Thanks, everyone.
So just quickly, Nicholas, in terms of doing code reviews or contributions and things like that, what's your are you a Kotlin person? Are you a Swift person? What's
I've done some work in Swift, but mainly Kotlin, Python, TypeScript,
okay.
and C. But so I'm capable of helping you guys review and whatever you need in terms of reviewing and testing those language implementations.
Awesome.
Yeah, so Nicholas was an intern of ours 2 years ago, and he got a job after the internship doing some work in Lightning and some other areas. And he's been lately doing some part-time sysadmin for us, and we're gonna try to bootstrap him into being able to help us with kind of build and PR management for this project. So the Wolf isn't overloaded on it, especially since Nick has built some Android stuff and has the the basic experience.
Yeah, cool. And finally, maybe Chris, a logistical thing. Would you, in terms of code and repo, excuse me, ownership, do you see these ports living in BC org with a whatever BC compatible license that we're all contributing to? Do you see these ports being like more similar to something like Hummingbird, where it's living in some other company's org that you just recommend as a reference implementation, or how do you foresee that?
Yeah, I'm not clear. So if it's something that, is by you or Bitmark, who are, real sponsors, and, I think there's some real good value in having it be under Blockchain Commons for sort of the long-term support, because it's, funded by you, et cetera. It's a little bit harder with things like Hummingbird, because they're not a Blockchain Commons sponsor directly, and it's hard for us to commit to a long-term thing on a project that we don't have long-term support for, or at least good support for now, so that we can say we can support it long-term.
Yeah, and mainly this is like, I guess this is a long-term maintenance question, right? Because for us, like from IP perspective, we're more than happy to have this live in a BC repo with your license on it that we are contributors to, as long as obviously the license is appropriately open. But yeah, that means that you're kind of taking on long-term ownership, and everyone else is a contributor, right?
So I think Python is actually the larger question. I'm not sure, we have the capability right now to support a Python project, whereas it feels like between Swift, Kotlin, and Rust, we're going to have to support those three for at least a few years, just because of the platform, issues right now. It's much easier for us to make a long-term commitment to those libraries. And I know that, Bitmark has already gone through, they've submitted one of their libraries. So they've already, thought through the, ability to commit to a joint CLA and work together. So that's my first preference for at least Kotlin.
Okay. Cool.
Or TypeScript. I've never quite understood when you can convert one to the others. So I know they're both similar, but not the same.
Yeah, I mean, TypeScript is its own beast. It's not really like, I mean, it started out as a like a layer on top of JavaScript, but it's very much its own thing now. It has a extremely powerful type system that, probably rivals Rust's. I actually suspect, just looking at Wolf's presentation, I suspect the TypeScript port will be the easiest probably, because it will always be like, it almost looks like it'll be a one-for-one mapping.
Okay, well, thank you. And thank you for asking on that. Let me know, when you need a repo and privs and all that kind of stuff, and I can start that. I think the Gordian developer signal channel is the best, short-term place. And of course, issues and PRs in the spec repo.
Awesome.
Okay. Well, thank you much, everybody, and onward and forward.
Thank you.
Thanks. Take care, everyone.
Thank you.
Thank you.
Thank you.